our lessons is I record them, Angela, and then I will post them to YouTube, and then I'll post the link to YouTube in our Week at a Glance. So that way, if you ever miss a lesson or you just want to try to understand it again, you can go back and watch the video of everything. All right, so here we go. Triangle congruence. This is what we were doing yesterday. That document we just went over. The triangle congruence theorems are what they're called. We came up with 5 of them that will always work. So out of the textbook, there are actually 5 lessons that go with this specific lesson, but I didn't really care for what was in the textbook, so instead I went through and found some different resources through mathisfun.com, and I linked that website in this lesson as well. Your essential question: if we do not know if all 3 sides and all 3 angles are congruent, how else can we determine if 2 triangles are congruent? And so when we have 2 triangles, we looked at this last semester, we have 2 triangles and it tells us that, hey, all 3 angles in both of them are exactly the same, and all 3 side lengths on both of the triangles are exactly the same. Then we can conclude those 2 triangles are congruent. That means they have the same shape, the same size. But what I'm showing you guys today is that, well, you don't actually have to know that all 3 sides and all 3 angles are exactly the same. You don't always need all that information. And so that's what we were kind of playing with yesterday in GeoGebra, is we were trying to create triangles that were not congruent. And we've seen that sometimes we don't have enough information, but there are certain cases where we do have enough. And so the learning goal today is that I can determine whether triangles are congruent using angle, side, angle, side, 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 angle, side, and hypotenuse leg. So these are our 5 congruence theorems that let us determine if 2 triangles are congruent without being told or being able to tell they're congruent, because we already know that all 3 angles and all 3 sides are the same. So we're going to start with a little video. I like these videos. They're from YouTube, and it does a really good job of explaining all 5 of these. Okay, so I'm going to show you the video, and then we're going to go through each of these, and we'll do some interactive slides together.
What's up, everyone? Welcome to this lesson where we're going to explore the different triangle congruence theorems. So let's start out by asking the question, what does congruence even mean? We like to think of it as this equal sign with the squiggly line over it, but let's just take a few moments to really conceptualize what congruence means, especially in terms of figures. So let's look at a running shoe. If I can somehow duplicate this running shoe and make an exact replica, I would say that these 2 shoes are congruent because they are exactly the same size and shape. Now, even if I change the color of one of the shoes, or I rotate it around a certain number of degrees, it's still congruent to the original sneaker because it's the same size and shape. And we want to extend this kind of thinking now to comparing triangles to see whether or not they are congruent. If their corresponding sides and angles have the same measure, then we can say that the triangles are congruent. And this applies even when the figures don't have the same orientation, and visually it's not so easy to tell whether or not these triangles are congruent, and this is where our theorems are going to come into play. So the goal of this lesson is to help you to understand why the theorems that we use prove congruence, and how to know which theorem to use in a particular situation. So here are the 5 triangle theorems with their abbreviations. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So now we're ready to go ahead and explore each theorem individually. Now the side, side, side triangle congruence theorem states that if in 2 triangles we have 3 pairs of corresponding sides that are congruent to each other, that means that they have the same length, then that's enough information to say that the triangles are congruent to each other. Which again just means that both triangles are exactly the same size and shape. So in this instance, we can use the side-side-side theorem to conclude that the triangles are congruent and that their corresponding sides and corresponding angles have the same measure. And remember that this relationship is still true even if the figures have different orientation. Our next theorem is side-angle-side. Now for this triangle congruence theorem, we start with a pair of corresponding congruent sides in two triangles. We also have a pair of corresponding angles that are congruent and another set of corresponding sides that are congruent. Now see that the letter A is in between the two S's in the name of the theorem? This corresponds with that congruent angle being in between the two congruent sides. Now, when this is the case, we have enough information to say that the two triangles are congruent by using the side-angle-side theorem. Our next congruence theorem is the angle-side-angle theorem. When we have two triangles with a pair of corresponding congruent angles, a pair of corresponding congruent sides, and another pair of corresponding congruent angles, we have enough information to prove congruence using angle-side-angle. Now, it's important to notice that the congruent side is in between the two congruent angles. And now we can visualize that when this is the case, we have enough information to prove that the two triangles are congruent by angle-side-angle, which means that all of their corresponding sides and corresponding angles have the same measure. Now, our next theorem is very similar to the one that we just looked at, which was angle-side-angle. This one is called angle-angle-side. Now, when in two triangles, we have a pair of corresponding congruent angles, along with a second pair of corresponding congruent angles, as well as a pair of corresponding congruent sides. Now, we don't want to confuse the last theorem, angle-side-angle, and this theorem of angle-angle-side, because both of them involve two congruent angles and one congruent side. The difference is that in angle-angle-side, the congruent angles are consecutive. That is, that they are one after the other. And then the congruent side is next to them instead of in between them. Now, even though the order is different, we still have enough information here to prove that these two triangles are congruent, which means again that their corresponding sides and corresponding angles have the same measure. Now, our final congruence theorem is kind of a special case. It's called hypotenuse leg, and it applies to right triangles only. So let's start out with the key feature of any right triangle, and that is a right angle. Now we know that the hypotenuse of a right triangle is its longest side and is always opposite the right angle. So this congruence theorem says that if the hypotenuse in both right triangles are congruent, and if a leg, which is one of the other sides, are congruent, that is, they have a pair of corresponding congruent sides, then that is enough to say that the two triangles are congruent. Again, which means that the triangle's corresponding sides and corresponding angles have the same measure. So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle-side-side? Please don't be uptight. Okay, so now let's go ahead and explore why angle-side-side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have two sets. We have an angle followed by two consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the two congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle-side-side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now, if I draw it this way as an acute triangle, I see that I have angle-side-side. However, The base of each triangle clearly are not the same, and these triangles clearly are not congruent.
Okay, so I think that's a fantastic video. It covers all of those theorems, why they work, why angle side side does not work. Okay, and so what we're going to do for this is just kind of go through each of those, and I put some more text in here for you, so that way when you do take your notes, you have some more stuff to go off of. But we're going to like do some examples, and I'm going to ask you guys if you think the two triangles are congruent or not on quite a few different problems here. So this is one of our congruence theorems, side, side, side. And so you can see this triangle in this example, 5, 4, 7. Over here, we have the same thing, 5, 4, 7. It's been flipped, okay? So there is a transformation that happened. It was reflected, but that still means they're congruent, same size, same shape, okay? And so this slide here is your first interactive one. Remember, guys, I need you to participate to get your attendance credits. So I have 26 of you in the hair deck. There's 28 of us in the meet. So there's 2 people in the meet that haven't joined the pair deck yet. And I do need everyone that is in the pair deck to respond. So what do you think? Do you think that the two triangles are congruent? Just given the information that you see. They are not drawn to scale. One triangle has sides 4, 3, 6. One triangle has sides 4, 3, 6. Can we say the two triangles are for sure congruent? Yes, no, or not enough information. About 10 more seconds. Make a choice. Most of you said yes, and you are correct. Yes is the correct answer, okay? This is this theorem here, side, side, side. So even though we don't see that the 3 angles are also the same, it is a theorem that says these two triangles are congruent because all 3 sides are congruent for both triangles. Okay, here's another one. It's important to note that these triangles are not drawn to scale. Are the two triangles congruent? The information that we have from this picture is that this length is 6 and this length is 6. This length is 4 and this length is 4. Are these two triangles congruent? Your choices are yes, no, not enough information. So go to your Pear Deck tab and choose either yes, no, or not enough information. Okay, so let's see what we came up with. 16 of you said yes. 3 of you said no. 2 of you said not enough information. So let me ask you a question. And you can just type in the chat or do a thumbs up or down. Is it possible that these two triangles are congruent? Is it possible that this unknown side length represents the same side length? Some mystery number. Is that possible? Okay, some thumbs up. Yes, that's true. Is it possible now, different question, that these two triangles are not congruent? That this side length here is actually a different length? Is it possible that they are not congruent? Adriana says yes. Nobody else wants to say anything. Yes, she's right. Okay, it is possible that these two side lengths are different. So remember, this is not to scale. So if this little piece here is slightly higher than this little piece here, these two lengths would be different. So what that means is that it is both possible for these two triangles to be congruent and also not be congruent, given just this fact that two sides are the same. We have side here, all right? And so this is kind of like ASS in a way, but even less than that. All we know is that two sides are the same. So we don't even know a third piece of it. We only have two pieces of the puzzle. So C is the correct answer here. It's possible for both triangles to be congruent, and it's also possible for them to both not be congruent. So there's not enough information to answer this question correctly. C is your correct answer. All right, so one more. You have two triangles. First triangle, side lengths of 6, 8, 10. Second triangle, side lengths of 4 and 5/10, 6, 7 and 5/10. They are not drawn to scale. Are the two triangles congruent? Yes, no, or not enough information. About 10 more seconds. Make a choice. Go to your Pear Deck tab and choose one of those answers. Okay. No, most of you said no, and you were correct. Okay, so if two triangles are congruent, they have exactly the same size and shape. These two triangles do not have the same size. They are most definitely, one is larger and the other one is smaller. So these are not congruent triangles. Okay, good. So that was side. Now we're looking at this theorem, side, angle, side. So if we know that a side, an angle, and a side are the same on two triangles, we can say the two triangles are congruent. And that's an example shown here, is that this triangle, we know this side length, we know this angle, and we know this side length. And then over here, we have that repeating. So it's the side, the angle, and the side. Side, angle, side. I showed you a problem back before where we just had two side lengths. There wasn't any information about an angle, but if I do know the angle is locked in, then we can say the two triangles are in fact congruent. Another theorem we have, okay, so we're reversing it. So instead of side, angle, side, we're looking at angle, side, angle. That's when you have an angle, a side, and an angle, okay, in that order. Or an angle, a side, an angle. And so when that happens, and that's all the information you're given, is one of the side lengths and then the two angles on either side of the side length, okay, it's locked in. These two triangles are definitely congruent. So take a look at this picture here. These two triangles are not drawn to scale. All right, one of the triangles, we are given the fact that one angle is 63 degrees, one angle is 72 degrees, and then the length, the side length in between those two angles, we have a 3 there. That's angle, side, angle. But then this other triangle over here, well, we have angle, side, nothing. We have side, angle, angle. But this is 45 degrees, this is 63 degrees, this is 63 degrees, this is 72 degrees. So what you need to do on this one before you can answer is you need to think about what do the three angles of any triangle add up to? 180 degrees, right? So you might have to do some little calculations here. What is this missing angle and what is this missing angle? And then we can use one of our theorems to determine if the two triangles are congruent. Okay, so what is the missing angle on the triangle on the left? This is 63, this is 72. If I add 63 and 72 together and then subtract that sum from 180, what is this missing angle? Yes, David, you're right, it's 45 degrees. So if this is 45 degrees, and over here, look at this one at 45, 63, well, this has to be 72, okay? And so now I know all three angles on both triangles are exactly the same. We know that one side length is the same. So is there a theorem that says some combination of the side length and the angles? What did you guys say? So is it yes, no, or not enough information? Yes, most of you said yes, you were correct. Yes is the correct answer. Okay. Yeah, you can use side. You can use, I'm sorry, angle, side, angle. Okay, so angle, side, angle then. Angle, side, angle. Or you can use angle, angle, side. Angle, angle, side. So you could do it either way, but both of those theorems are proving that those are congruent triangles with our limited amount of information. We could figure it out. All right, this theorem here, angle, angle, side. So an example of that, two angles in a row and then a side, two angles in a row and then a side. These would be congruent. So are these two triangles congruent? Does this follow angle, angle, side? I'm going to answer in Pear Deck and then go ahead and come back to the meat. Are those two triangles congruent? If I know there is a rule that says angle, angle, side, and that would prove two triangles are congruent. Does that apply here? Are they congruent? About 10 more seconds, make a choice. All right, let's see what you guys came up with. Most of you said no. No is correct. So just look at these angles here. We have 66 degrees and 49 degrees. Over here, we have 74 degrees and 63 degrees. So these two triangles do not and cannot have the same three angles because they would have to already share a common angle just right from what we're looking at. Their three angle measures are different, and congruent triangles have to have the same angle measures. They're not congruent if they're different shapes. So no is the answer here. All right, I know we're going kind of fast. We have 5 minutes left. I made probably this presentation too long. Okay, real quick, what is the Pythagorean theorem? You guys remember what it is? You can type it or draw it in the box. You have to remember to last year, last semester. You can use combination of typing and drawing, or you can just draw it. You can search it up on Google. That's a great idea. Use the resources that are here for you. Nice. What is the Pythagorean theorem? I have about, I think some of you are typing, so it looks smaller, but some of you are coming up with it. I'll give you about, I know, I want to give you more time. Let me see. What do we have to do after this slide? Let's see what we came up with. We're down to 3 minutes. Okay, here we go. A squared plus B squared is C squared. That is the Pythagorean theorem, absolutely. Someone's going to draw a right triangle. That's a good idea. A squared plus B squared is C squared. They wrote it out. That works too. Okay, so good. So the last triangle congruence theorem involves right triangles only. It's very, very specific. So Pythagorean theorem, that deals with right triangles. We're talking about right triangles only when we talk about hypotenuse leg. If you know the hypotenuse and the leg are the same, then you can say triangles are congruent. All right. I'm not going to go through all this text right here, but you can go back to it. I'll put you in student pace when we're all done. This is the last one that's like math related question. Okay. Look at those two triangles. Are they congruent? This may have nothing to do with hypotenuse leg. It has, I'll just tell you, it has nothing to do with hypotenuse leg because hypotenuse leg only works on right triangles. So this last math question is just a general question. Think about everything that we have talked about today. Think about the triangle congruence assignment you had yesterday. Are those two triangles congruent? I'll give you till 39, and then I'll show you the answers that you came up with. It is 39 right now. Most of you overwhelmingly say yes. It's possible. Let me say that. Yes is a possible answer. Because what is it that these two triangles have in common? 37, 37, 85, 85, 58, 58. This is, right, Adriana, this is angle, angle, angle. Is it possible to make two triangles that are not congruent with angle, angle, angle? We did this, remember? If I come back over here and share this one, where's it at? Angle, angle, angle. It is possible to make two triangles that are not congruent. So you should be changing your answer from yes, not to no, but to not enough information. Okay? It is possible both ways. Yes, these could be congruent, okay? But also they could not be congruent. We don't know. There's just not enough information to make that determination. Okay, so not enough information. C, not enough information. Oh my gosh, it's 11:40. Gosh. Okay, class is over except for you have one slide left. How do you feel? And then I'm going to put it on student pace mode. And you could go take a 5-minute break. And then you can come back and do your asynchronous work. You're allowed to leave the meet or you can stay on the meet. I can answer any questions you may have. So have a wonderful day. And I'll keep chat on in GoGuardian to help you with anything you're working on as well. Your async work, so let me just show you in the week at a glance. So the way it's set up now is we're over here on Thursday. Sometimes my mouse doesn't show up and I wish it would. Oh, there it is. It's like just blinking. I don't know why it does that. It does it on docs. It's weird. So it's this teal area under Thursday. I'm going to process the video lesson, which typically